The key to success in working with percents in stoichiometry, is understanding the concept of percents. In this problem, we have a system of equations. We have two equations. In the first one, we take P4O10 and we produce phosphoric acid. In the second one, we take zinc and allow it to react with that phosphoric acid, producing zinc phosphate and hydrogen gas. Now, we want to calculate the mass of zinc phosphate produced when zinc is allowed to react with a phosphoric acid that is formed from 10 grams of P4O10. And then we're going to add a wrinkle to the problem. And the wrinkle is down at the bottom. If only 19.3 grams of the zinc phosphate was recovered, what is the percent yield? Well, let's work the problem first. If you don't have experience in working calculations from chemical equations, you might want to go back and look at an earlier lesson on that. But anyway, we have 10 grams of P4O10, and we want to know what mass of zinc phosphate is going to be produced. Well, we start out with our 10 grams of P4O10 and we convert that to moles. And we know that 1 mole of P4O10 weighs 284 grams. Now, how do we get from P4O10 to zinc phosphate? We have to use something in the first equation that connects to the second equation. And the thing we will use is the phosphoric acid. So, in the first equation, we go from P4O10 to phosphoric acid. And that is 4 moles of phosphoric acid to every 1 mole of P4O10. But that phosphoric acid that is produced is exactly the same amount that is consumed in the second equation. So now we're ready to go to zinc phosphate. And what is the mole-to-mole ratio there? Well, it is 1 mole of zinc phosphate over 2 moles of phosphoric acid. We are now at moles of zinc phosphate. We multiply that by 386 grams per mole, which is the gram molecular weight of zinc phosphate, and we come out with 27.2 grams. And that's the weight of zinc phosphate that could be produced if everything were perfect. But what if we only captured 19.3 grams? Maybe we spilled some. Maybe the reagents weren't good. Maybe we didn't weigh something right. Who knows? But what is the percent yield? Well, we have 19.3 grams that we retrieved. We should have retrieved theoretically 27.2 grams. Multiply that by 100, and we see that we have a 71% yield. This is the kind of problem that gives students an awful lot of difficulty because we're asking you to find how much of an impure substance you should use. In this problem, we're going to use the same series of equations that we used in the previous problem. We're going to have P4O10 reacting with water to produce phosphoric acid, and we're going to take that phosphoric acid and allow it to react with zinc. The thing is, we have 6 grams of zinc that needs to react. But the P4O10 that we have in the first reaction is only 47.2% pure. And the question is, how much of that impure reagent do we need to have to react with zinc, to produce enough acid to react with zinc? Well, what we're going to do is start with our zinc and go from zinc to phosphoric acid. And then once we find how much phosphoric acid we need, we're going to go from phosphoric acid to P4O10. But we're going to assume in all of this first procedure that everything is pure and perfect. Let's see how to do this. We start with 6 grams of zinc. We convert it to moles. That's 1 mole over 65.4 grams, the gram atomic weight of zinc. That gives us the moles of zinc. And now we go to moles of phosphoric acid. The moles of phosphoric acid can be found by using the mole-to-mole ratio of 2 moles of phosphoric acid to 3 moles of zinc. Now we're at moles of phosphoric acid. We can go to moles of P4O10. And we see that it is 1 mole of P4O10 that will produce 4 moles of phosphoric acid. Now we're at moles of P4O10, and we can find the mass of the P4O10 used by multiplying by the gram molecular weight of 284 grams per mole. This gives us 4.34 grams of pure P4O10. But folks, our source is only 47.2% pure. So how do we find out how much of the impure P4O10 we need? How much do we need? I don't know. We need X. So that 47.2% of X is 4.34 grams. Do you recall from your math that when you say such and such a percent of something, that means multiply? So the expression then is 0.472x equals 4.34 grams. Solving then, we find that X is 9.2 grams of our impure P4O10. Be very careful now. Note how you handle the percents when you're working this problem in a sort of backwards fashion. Well, I hope this has helped. Brought to you courtesy of Chemistry Professor, offering complete courses on DVD. Visit us at our website, www.chemistryprofessor.com.